Example 8, applied vectors operation. It says, a soccer player is running forward at 7 meters per second, kicks a soccer ball with a velocity of 30 meters per second and an angle of 10 degrees with horizontal. What is the resultant speed and direction of the kick? Now remember, resultant means we're adding two vectors together. That's what this word means here. So let's look at the picture. There are two vectors here. One is that she's running horizontally. The second is that she kicks the ball basically horizontal, but with a little angle to it. So with our vectors, if we're doing a resultant, we just add them together. With a calculator, we just need to label these vectors. Now this one, you'd ask yourself, is it an x or y, or is it given as an h and angle? The answer is, it's given as an x and y. We know that we're running along the ground, which means she's running 7 meters per second to the right, but she's not leaving the ground at all. She's staying, the y values are not increasing or decreasing. She's staying flat. So that's that vector. This vector is given in the h and the angle form. So this vector is, the hypotenuse is 30 meters per second, and she's running at 10 degrees from the x-axis, which is the form the calculator wants. If we add those together, we should get the right answer. So I'll just write them over here again, 30, comma, 10 degrees added to the speed of her running will give you actually how far that ball will travel. So this is like if she kicked flat-footed, this is how far it would travel. But with running, the ball will travel further. So let's see what we get when we go to the calculator. So clear this out. You go control parentheses to get those symbols. And now the values were 30, comma, the angle is control book. If you press control book, you'll see it there. And the angle was 10 degrees from the horizontal. And we're going to add that to her sprinting speed, which was 7 units right, 7 meters per second right, without going up or down. When we press enter, that's our value as an x and y. So the ball will travel 36.5 meters per second to the right, and it'll travel up 5.2 meters. Now, obviously, gravity's not in there, but that is a x and y. If I want it as an h and theta, I go menu, 7 for vectors, and then I'll choose C for vectors again, and then convert it to polar. There it is as an h and an angle. So we get 36.9 and 8.1. 36.9, I believe is what it was. Yes, and 8.1. And so this would be the speed, that would be the direction. And here's just a diagram of what's happening. They're running, they're kicking, this is our value. So let me write this out here. And then, so this is 36.9 meters per second. And the direction is 8.1 degrees. Now, what if you're at home and you don't have a calculator? You might be thinking, how do I do this? Well, the way you'll have to write it is at home, this part's easy. You could, I know it looks like you should add those and get 37. We don't. That's because this is h and a theta. What you would have to do is know that, if you remember from earlier in the year, that cosine theta started off, you know that cosine theta is equal to x over h, and sine theta is equal to y over h. Well, what you do is to convert from one form to the other is to get the y by itself, I'd multiply both sides by h. To get the x by itself, and multiply both sides by h. And so basically we know that x is the same thing as h cosine, and that y is the same thing, when we cancel this, as h sine. Now what does that do for me if I'm at home? Well, if I need to figure out this addition, what I would do at home, and since you're at home, I'll just use this symbol. As the vector, this would be 30, that's my h. This is an h. So you'd say 30 cosine of 10 degrees. And then here, this would be, for my y, would be 30 h sine, 30 sine of 10 degrees. And you would add that to vector 7, 0. Now, any calculator at home could probably figure this out for you. You would add your x with x and your y with y. I'll show you how it'll work. So we go over here. We'd have the 30 cos of 10 degrees. And then I would add that with the other x. The other x was 7. So when I add that with 7, it should give me the same value there that it does. And now I do the same thing, but this time I do 30 sine of 10 degrees. And you would add the y value, which if you remember was 0. So adding 0 won't change anything. This gives me that y value. So that's the same way of getting the values, it's just it's longer. And so that also gave us the vector 36.9. Rather, that gave us the x value, I'm sorry. That gave us this x value, which would be 36.5, comma 5.2. Once you have your x and y, to find the h, you do Pythagorean theorem. And to find the angle, you would do like an inverse tangent of y over x. And that's how you would get that